So the farther they fall, the more energy is released and the higher the frequency. So the orbitals also have different energies inside energy level. So we can see here that delta E, okay, this is the Planck constant equation. So this is how we relate between delta E and wavelength, and also delta E and also frequency. So delta E is inversely proportional to wavelength, meanwhile it is directly proportional to frequency. So let's do this question. The following diagram depicts the line spectrum of hydrogen atom. Line A is the first line of the Riemann series. So you can see the wavelength decreases. Okay, the distance between the line, the space between the line decreases. So we say that the wavelength decreases. So that's mean delta E increases and frequency increases. Specify the increasing order of the radiant energy, frequency and wavelength of the emitted photon. Which of the line that correspond to the shortest wavelength? So the shortest wavelength means that from left to right wavelength decreases. So the shortest wavelength belongs to line A. Right? Meanwhile, the lowest frequency from left to right frequency increases. So the lowest frequency will be line A. Good. Okay, next, this is the Paschen series. Okay, this is the line spectrum for Paschen series. Which of the line in the Paschen series correspond to the longest wavelength of photon? Next, describe the transition that gives rise to the line. So now we can see from left to right the gap between the line increases. So that's mean frequency increases. Okay, delta E decreases. Frequency decreases. So which of the line correspond to the longest wavelength? So longest wavelength should belong to line A, right? Because wavelength from left to right wavelength increases. So the highest wavelength should belong to line A. Right? Describe the transition. Since this is the Paschen series, Lehmann balik pasar. So that's mean its final or its ground state equal to 3. Lehmann balik pasar. So the first line, this is the first line. Okay, this is the first line. Line A is the first line. How do we know? The first line will have the lowest energy. So this is the first line. So the first line, the formula you can use is NF plus number of line. NF plus number of line equal to N initial. That's mean the transition will fall from N initial to N final. So now N final or the ground state is 3. A is the first line plus 1 equal to 4. So that's mean the electron fall from N equal to 4 to N equal to 3, right? So the electron moves or transit from N equal to 4 to N equal to 3. Simple. So you can use this formula. And final means its ground state. And final means its ground state, the electron, the ground state of the electron. And initial means the excited state. Okay. So next, this is the Boltzmann series. So Boltzmann series N final equal to 2. That means its ground state, the electron will fall to N equal to 2. So as we can see from left to right, the wavelength decreases. Delta E increases, frequency increases. Describe the transition of electron that will lead to line W and Y. So since this is the lowest energy, right? So this is the first line. This is the second line, third, fourth, and fifth. So remember, you can use the formula N final plus number of line equal to N initial. So as for W, this is the second line. So N final equal to 2, 2 plus 2 equal to 4. So line W is formed when electron fall from fourth energy level to the second energy level. So that's mean electron fall from N equal to 4 to N equal to 2. Meanwhile, for Y, NF plus number of line equal to N initial. So N final or the ground state is 2 plus 5 equal to 7. That's mean line Y is formed when electron fall from N equal to 7 to N equal to 2. right? So this is the answer. You must write when the question asks you to describe. That's mean you must say the transition of electron or electron fall from which energy level to which energy level. Okay. So this is the Rydberg equation. It is used to calculate the wavelength of any line in the given series. Okay, so this is the formula. 1 over lambda equal to RH, Rydberg constant, bracket 1 over n 1 square minus 1 over n2 square, where n1, okay, you must use n1 is less than n2, or is n1 is smaller than n2. So lambda is wavelength, okay, n is the principal quantum number, RH is the Rydberg constant. When you want to calculate frequency, please use this value, because we know there are two values of Rydberg constant. Okay, so you must use this value for calculating the lambda. Okay, lambda must be more than 0. That means it cannot have a negative value. So when you get negative value of lambda, that means something wrong with your calculation. That means you mistakenly, okay, substitute the value. So please make sure when you want to substitute the value, n1 must be smaller than n2. Okay, regardless of the starting point. So use the Rydberg equation to calculate the wavelength of the fourth line in the Balmer series. So we can fourth line. Okay, so by using the formula Balmer NF or its ground state equal to 2. So NF plus number of lines. Okay, equal to N initial. Right? So now NF equal to 2, fourth line. So that means electron will transit from n equal to 6 to n equal to 2. So that means fourth line of Balmer series is formed when electron falls from n equal to 6 to n equal to 2. So the question asks you to calculate the wavelength. Okay, so you must use 1 over lambda equal to RH 1 over n 1 square minus 1 over n2 square, where n1 is smaller than n2. So we have 2 and 6, right? Which one is smaller? Of course 2. Therefore n1 is 2. Okay, so 1 over lambda equal to, substitute the value of the Rydberg constant per meter. 1 over n1 should be the smaller number, which is 2, minus 1 over n2 square. Don't forget the square. Okay, so calculate and you will get, first you will get 1 over lambda, but the question asks you lambda. So in order to get the lambda, 1 over an answer. So you get the lambda and then convert it into nanometer, which is 10 to the power of negative 9. Okay. So this is example. Okay, substitute the value. Please make sure n2 smaller than 6. Okay, and 1 is smaller than n2. This is the value of 1 over lambda. Okay, so in order to get lambda, 1 over this answer. Okay, so first you will get in 10 to the power of negative 7. So in order to convert it into 10 to the power of negative 9, just move it. Use the Rydberg equation to calculate the wavelength, okay, in nanometer of the photon emitted when a hydrogen atom undergoes a transition from n equal to 5 to n equal to 2. So simple, between 2 and 5, 2 is smaller. So 2 should be n1, okay, and 5 should be n2. Okay, and then just substitute into the equation. Okay, 1 over lambda equal to RH 1 over n1 square minus 1 over n2 square, where n1 is smaller than n2. So substitute the value. RH is 1.097 times 10 to the power of 7. Okay, 1 over n1 should be a lower number. Okay, then calculate and then convert it into nanometer. Make sure, okay, convert it into nanometer, because the question asks you in nanometer. Okay, reminder. So we know that there are two Rydberg equations. So this first one is used to calculate the delta E, meanwhile the second one is used to calculate the wavelength. But actually, from this Rydberg equation, we can calculate also. Once we've got the delta E, we can calculate the lambda as well by using the Planck constant equation. Delta E equal to hc over lambda. Okay, so n1 can be an initial or final as long as n1 is smaller than n2, because as I said, we must ensure that n1 is smaller than n2 in order to get a positive value of lambda. We will never have a negative value of lambda because it is wavelength. Wavelength, that means something measurable. Okay, so please make sure you have a positive value of lambda. Okay, so both equations can be used to calculate wavelength and frequency of any line of hydrogen atom emission series. Okay, remember, Rydberg constant values and units are different in both equations. So when using this equation, you must make sure you use the 2.18 10 to the power of negative 17 joule because energy. Meanwhile, when you are using this equation, please make sure you use the unit per meter because wavelength, right? So please use the per meter one because wavelength. Okay. So an electron in the n equal to 5 level emits a photon of wavelength 1281 nanometer. To what energy level does the electron move? So now we have n. This is n2 because it falls from n equal to 5 to a lower energy level. That means n1 is smaller. So now you have to calculate n1, okay, given the value of wavelength. Don't forget to convert it into meter because we need to cancel the unit meter. Okay, so we can see here. Okay, substitute the value must be in meter, not nanometer, because we are going to cancel this unit. Right, so please make sure the given value 1281 nanometer, please convert it into meter first by timing by exponent 10 exponent negative 9. Okay, then substitute the correct Rydberg constant. Then you know n5 is n equal to 5 is the n2 because it belongs to the higher energy level because the electron fall from must be from higher energy level to lower energy level. So that means the unknown is n1. So you must calculate the n1 equal to 3. Okay, calculate what is wavelength. So for Lyman series, n1 equal to 1 and n2 equal to infinity. So you must calculate the wavelength. Okay, you can use the Rydberg equation, and then once you got the wavelength, you can calculate the frequency, and then you can calculate the wave number of the last line of hydrogen spectrum. Wave number means 1 over wavelength. So this is the answer, right? And this is the calculation. N1 equal to 1, N2 equal to infinity. 1 over infinity equal to 0. Right? Therefore, the value of 1 over lambda equal to the value of Rydberg constant because this Rydberg constant times by 1 equal to its value again. And then when we want to calculate lambda, 1 over this answer, you will get lambda. Next, once you have the lambda, you can calculate the frequency. Next, wave number. It asks you to calculate the wave number of the last line. Last line means when the N2 is the infinity. Okay, so wave number, this formula is the wave number 1 over lambda. Okay, so here are the exercises that you need to do. Okay, please do it by yourself. Calculate the wavelengths and frequency. So first you must use the Rydberg equation to get the wavelength, and then you can use the speed of light to calculate the frequency. So in particular, electronic transition, photon, okay, with the frequency. So this is the frequency. Calculate the difference in energy. So you can use the formula delta E equal to HV to calculate value of delta E. But that's for one electron. But now it asks you to answer in kJ per mole. That means you have to times by the Avogadro constant. So please do it by yourself and get the answer.